Thank you, David. Nice to meet you here. Yes, you already told us my talk is about loudness for German youth channel radio. It's called DASDING. The channel mainly broadcasts techno and hip-hop music with some news and spoken word contributions. It was the third station we introduced loudness in the SWR. DASDING, the channel, had to start as a multimedia platform in the late 90s because no FM frequencies were approved for them at that time. DASDING began using studio webcams with automated editing to provide a full video signal for social media, and that's how they started in the internet. DASDING also operates a small video division to produce topics for TV. Also, some German pop festivals are broadcasted on DASDING by radio, television, or in the internet. That is why the staff always stumbled about different loudness target levels. Introducing loudness made the work very much easier for them. The crew is also an innovation lab for the SWR. It was an exciting start for us. An exciting step for us, but against our expectations, we faced no longer discussions or fears or reservations from the staff there. They were very interested in loudness, and we had an easy collaboration with the crew. We heard about some complaints that could not be solved in the past by the crew. The first thing is that speech intelligibility was not always perfect. Some voices could not well understand. Another thing was loudness jumps. They had loudness jumps at the output of the mixing desk, which caused the AGC, the automatic gain control of the Optimode, to level incorrect. Another thing, some hosts told us that it's difficult to adjust the balance of different sources. They are very much inconsistent. Telephone compared to microphone compared to incoming lines and so on. And another thing, we measured the mixer output, and we realized that the loudness range is about 10, 12, or even 15 LU. This is a lot, and this is a movie dynamic and not a dynamic for a radio program. A good loudness range would be 3 or from 3 to 6 LU or something like that. The video production crew has difficulties to manage different cultures of producing audio. They need to support -23 LUFS for television, -16 LUFS for the internet, and for the FM radio something in between. Let me talk about the signal chain, about the signal flow in a broadcast studio. First of all, I want to say we have never intended to change the loudness on the listener's side. We are talking, when we talk about loudness, we talk about the studio, about production, and not about the loudness on the listener's side. We know about the hard competition between different stations, and to lower loudness means that we would lose listeners, and of course this is not what we want. To underline this, we divided the signal flow in two fields. One field is production, this is here on the left side, and the other field is distribution on the right side. During production, we introduce a loudness target of -23 LUFS. It is to say that during production, we speak in relative terms, so we always talk about 0 LU, which means -23 LUFS. During distribution, we use absolute values. We talk about -16, -18, -20 LUFS. This is easier to understand. And this is the switching point here between production and distribution. The distribution changes the loudness, the -23, to a loudness that is necessary to be successful in the market. Yeah, here we can see the values. On the left side, we agree on 0 LU, and on the right side, as I told you, we switch or we gain the signal to -18, -16, whatever is necessary. And this is what we achieved in the SWR. It's a note which was sent to all the departments by the head of department to end the discussions about loudness. This says that the program exchange in our in-house exchange has always be compliant to minus 23 LUFS. Now let's have a look to loudness measuring. We discussed with the presenters how we could best support them with the loudness display. We use a small device. You know that device, I think. We only use a short-term bar graph measuring the current program signal. Short-term is the best choice for leveling speech because of the 3 seconds integration time. It measures whole sentences, it measures the breathing included, and this results in a very slow changing display. Because the bar moves very slowly, a short-term display is always easy to understand. In every moment you watch the display, it shows you a good signal you can trust. This is a difference to a level meter. Another thing, we connected the microphone fader, the microphone fader switch to the GPI of the loudness meter. You see here a start and a stop button. This start and stop is used by the fader switch of the microphone. So if the microphone opens and the red light in the studio on air switches on, the loudness meter here starts measuring integrated loudness. And after the announcement is finished, you can read here the numbers, and you have a numerical display of the loudness of your announcement. This is especially a good thing for news presenters. They cannot check the loudness meter during reading, but they can check the loudness after reading, and they see 0.4 LU. This is a very good thing for a presenter. Yes, the most obvious difference between loudness and peak level is that the target value is in the middle, the red line here, and the dynamic range and not at the top end of the scale. We use the same color, blue, in the area below and in the upper area. In the center, you see a green range of plus minus 2 LU around the target. This is to help the host to keep the signal close to the target value. It's easier if you have a little range here instead just a line. So if the signal stays in this green area, it's good. Engineers like to use both momentary and short term. If we use momentary, we give the green range a tolerance of plus minus 3 LU. On a momentary display, you can even get a feeling for the speech intelligibility because you can recognize the volume of individual words or just syllables. If the signal stays in the green range of a momentary loudness bar, you can be sure that it is well understood also in a mobile listening environment. Let's go back to the broadcast signal flow. The aim is to get a well-balanced signal. Our approach is using loudness tools to normalize each individual input signal to minus 23 LUFS. This means that the program as a whole also is conformed to minus 23 LUFS. Introducing loudness to a pop program clearly means to reduce the overall level. The difference is probably 5 dB or 7 dB. In most cases, the automatic gain control of the FM processor, which is often Optimode or whatever, the input automatic gain control will compensate this. In our case, it did compensate it, so no change of parameters at the Optimode was necessary. If not, it can be necessary to increase the input gain of the processing stage accordingly. To normalize all inputs on the left side here, the microphone, telephone, outside broadcasting van, or the audio files, we have to distinguish two kinds of signals. The first group is this one. The first group is or are the live signals that are not compliant to EBU R128. microphones, telephones, line signals that are not really predictable regarding the loudness. The second group below are signals that can be compliant to R128. These signals can be normalized at the OB van, for example, or by using a digital workstation in your content management system. Now let's talk about voice processing. This is channel processing with an expander. We use an expander to reduce breathing noise just by 3 or 4 dB, just a little. And then for the next is compressor, and the next then is the R128 leveler. It is necessary to use different attack and release times of these 3 stages so that the processes do not work against each other. A level-based compressor can achieve a loudness target with a tolerance of about ±3 LU. This is a good thing, but it's not perfect enough. Therefore, we need a range of about 3 or 4 LU for the leveler. It is necessary to limit all level changes in all units to a meaningful value, 3 or 4 LU for the leveler, to avoid dysfunctions. One dysfunction could be if the leveler increases gain because of noise in the studio. For example, if the host does a phone call with his children or whatever, or by the loudspeaker in the room, which is switched on with music, this can force the leveler to gain. But to avoid this, we connect the leveler freeze signal to the fader switch. If the fader is closed, the leveler freezes. That solves the problem. Just a few words. I think I'm running out of time here. Just a few words to the compressor. For many years, we were using compression characteristic showed in the left figure. Threshold and ratio are rather high. While looking for reasons why the intelligibility of some voices was poor, we found out that the compression curve on the left is not perfect. 2 different voices trigger the compression curve at 2 different parts. The one is very loud and gets very much compressed, and the other one is softer and it keeps a natural sound. It's not compressed. And so it's better to use the right compression, the compression curve on the right side. Then two different voices get the same compression, the same amount of compression. And this compression curve attaches loud syllables or loud words as well as soft syllables. So it works on both sides, on the loud side and on the soft side. And therefore you can reduce the ratio from 1 to 4 on the left side to 1 to 2 on the right side. This is much more efficient here on the right side. Now let's have a look to the signals that are already compliant to R128. The OB van is no problem. The engineer in the OB van manages this perfectly. What we have to do in our studio is to manage audio files. This is how we manage audio files. We have a content management system and a playout system, and we use a digital audio workstation that works like a plugin for the playout system. The DAV works 20 times of real time. It needs just a second or less than a second for a news clip to normalize it. And if you have an announcement for a program item, the time for the announcement is enough to normalize the file. And this is what we what we do, what the digital audio workstation has to do. We distinguish between speech items, music, and sound design, which I mean trailers and such things, and we tell the system normalize the loudness to 0 LU and normalize also the loudness range, or limit the loudness range of the audio files for speech to 3 LU, for music to 6 LU. And this is the way we get a smooth program signal for dusting. In the end, after the project was finished, we were really happy because we solved all complaints and we got some benefits, like the hosts are relieved, or we can do much more automation during the night, music played during the night. It's easier for production, and also easier for the people working with multimedia content.